Thank you for the introduction. I'm Xinyi Wang from Southeast University, China. Today, I would like to show my work about early personalized treatment prediction model derived from subgroup in depression. Well, as we all know, major depressive disorder had a very high recurrence rate. And in the field of depressive treatment, only less than 50% patients could respond to the first-line treatment. In addition, the heterogeneity of MDD stands in the way of getting personal treatment. Hence, this individual difference needs a precision models for each patient. So, we develop a model which personalized prediction model, and we apply a theme of subtypes to increase the homogeneity. We hypothesized that MDD patient would be represented in distinct subgroups, and each biotype could be represented as distinct treatment strategies. We aimed to establish a model which tends to tell the clinical what drugs or intervention to prescribe for a specific individuals. To achieve this goal, we propose a two-stage pipeline. First, all the MDD patients were divided into distinct subgroups according to the symptom guide connectant. And each subgroup have their specific treatment strategies, such as antidepressant, cognitive behavioral treatment, or stimulation treatment. At the second stage, according to subgroup-based similarity estimation, we assigned a new patient in the external data size to one of predefined subgroup, which has a highest similarity with him. Next, his possible treatment strategies is to be expected to be consistent with that subgroup. Here is our study. Our study was a naturalism study using a real-world data. At first, the 489 participants were enrolled from 3 sites. At baseline, they underwent a resting state function MRI. Because of dropout and disease conditions, finally, the 228 MRI data were used in stage 1, and the 89 data were used in stage 2 to validate our model. Here, in this part, we show a workflow of our future constructions. Firstly, after pre-processing, the both time signal were extracted from the 28 region of interest in 4 treatment-related network. And previous studies speculate that this network may be helped to guide the treatment selections. Then the inter-network and intra-network functional connectivity were calculated. We respectively perform a cognitive correlation analysis between the selected connection and the 3 symptomatic factor scored. We repeat this distribution 3 times. Finally, the 3 cognitive variables was identified, and the hierarchical course analysis with these 3 cognitive variables to identify the subgroup. Here is our result. We have found 3 distinguished subgroups, and each subgroup has their specific treatment strategies, which is decided by a normalized distribution score we can saw in the figure A. And this score quantitatively measures the normalized proportion of each intervention of a responder in that subgroup. When the score is more than 1, which indicates this treatment strategy holds a dominant position in that subgroup. According to the normalized distribution score, the 3 subgroups were speculated as an SSR oriented and physiotherapy-oriented and SNRI-oriented. SSRI and SNRI are both typical antidepressants. Another important result is our abnormal connection profiles. In this part, we can see the three subgroups have this specific abnormal pattern. It's notable that subgroup C has the largest number of abnormal connections, which may account for the highest depressive severity of subgroup C. Finally, the most important part is our model performance. We displayed our performance by a confusion matrix. And as we all know, our study was a naturalism study, so patient intervention was decided by a attending doctor rather than our model output. So the patient's frontal side we divide into two parts. First is the real intervention is consistent with our model output. Another was not. So we separately accounted the treatment account about these two parts. The sensitivity is measure the probability of the improver, and the specificity measure the predictability of non-improver. Our model achieved a better performance of predicting effective treatment. Finally, there are a large number of neuroimaging biomarkers have been identified, but yet this knowledge has not yet translated to the treatment recommendation. So our research is a temper in the clinical practice. Compared with the clinical symptom and the brain connectant, we identified a treatment-related subgroup rather than the diagnostic subgroup. And instead of a single type of biomarker, our model integrates multiple resources and focus the similarity between the patients. And we use two independent samples to test our data, so we have a better generalization and robustness. Finally, and thank you to all the members of our lab, especially for my supervisor, Professor Lu and Professor Yao. And thank you for your listening. Thanks.